Now we have a summary of geometric sequences, again from Unit 7, Lesson 2. You're playing a crazy monkey game where you earn points for eating bananas. Each banana you eat is worth 3 times as much as the last banana was. You get 1 point by just starting the game. So when you put a coin in, you get a point. Complete the following table for points you will earn for eating the bananas. Well, eating no bananas, you already get a point for just playing. Participation goals here. Then you eat the first banana. You had 3 points, and so even though you haven't eaten a banana, and for all general purposes here, we're going to say that this is 3 points for the first banana, because 1 times 3 is 3. Even though that wasn't a banana, go along with me here for now. The second banana then is worth 3 times as much as the last banana, so that'd be 9 points. 3 times as much as the second banana would make the third banana worth 27, and then the fourth banana worth 81 as we complete the table. What type of sequence is this? Again, we have a hint, but it's geometric. And that is because each time our table is getting the next entry by multiplying by a number. So geometric is because it's multiplying by 3 each time. Now we need a recursive formula. Again, this is the subscript notation, and the letters don't really matter, but I had used points from the bananas. So since b plus 1 and b are being recommended to be used, we're going to put the p sub b plus 1 out front, because that'd be a banana after the p sub b banana. That makes sense. So we will take our 3 times the points for the banana we're currently on to get our points for the banana that we eat next. Now again, with recursive, it's important to have the initial amount of points. So p sub 0 equals 1. That way someone knows where to start from in their table or with their function. Now, for function formula, again, we want to make sure that if someone would ever plug in 0, they get 1, or they plug in 1 and they get 3. Recommend that you always check your function formula with the actual table data. So we'll start out p of b. Now, this grows pretty quickly, and you may have talked about it in class, but this formula is basically exponential. It's not growing steadily like an arithmetic is, like a linear pattern. So we don't have a line equation this time, we have an exponential. So in this case, we put our initial starting value, our beginning amount of points, times 3 to the n, or the b, I guess you could say, the bananas. Now let's think about this. Again, this might be something you're kind of confused with how you come up with. We know it's exponential because it's multiplying. It's growing very, very quickly. And if you graph this pattern at all, you would see it grow quite quickly like an exponential. But to check your formula, remember geometric sequences always have an exponential look, and this is always your beginning term, and 3 to the b. Let's plug in 1. If I eat 1 banana, 3 to the first power is 3, times 1 makes 3, and that matches. If I eat 3 bananas, 3 to the third power is 27, times 1. This times 1 doesn't do much, but there are times maybe you play a game and the original amount of points they give you is 7. Well, then you have to go 7 times 3 and that number times 3. I kept it low for easy multiplication purposes. But again, this is always your beginning term. And this one would be 3, your multiplier, to the bananas you're eating. And it works for that formula. Again, please always check if your formula works for your table. That way, when they want p of 8, I can just plug it into this formula and feel confident it will work. Well, that would be 1 times 3 to the 8th. And one moment while I calculate that here. It's going to be a large number of points. 3 to the 8th power times 1 gives us 6,561 points. We are rocking it. That would mean that if I ate on the 8th banana, it would be worth that many points.